space, no one can hear you scream.
Pwede bang mag-coexist ang science at spirituality natin?
Let's see if mapapaswipe right kayo or mapapaswipe left kayo kay Daniel Kolak. Born in 1955 in Zagreb, Croatia, professor of philosophy at William Patterson U, New Jersey, Dr. Daniel Kolak is one of the most prolific philosophers in the world. Kolak is a contemporary philosopher with his numerous articles, stories, essays, books, and other creative works that bridge traditional philosophy from neuroscience to quantum mechanics, from logic and mathematics to art, music, and literature. Work focus on the history of philosophy, philosophy of mind and language, physics and mathematics, and arts. With over 35 authored books and nearly 200 books edited, his best-known recent works are I and You, The Metaphysical Foundations for Global Ethics, all about open individualism. Another would be The Experience of Philosophy, which challenges students thinking about God, freedom, reality, nothingness, death, and even their own identities. From this book, we will focus on his passage on the Church of Science.
Before I ask you the question, I want you to think about something first. When I ask you what you know about the day and the year and its relation to Earth's movement, you would probably think about this: the Earth's rotation and revolution. A day passes by differently in different parts of the world because the different areas of the Earth face the Sun and the Moon in different times, because a round thing can't possibly face the Sun or the Moon all at the same time. We'd have to be living on a flat Earth. So how does a day pass by then? We all know the Earth isn't flat. The Aristotle-Ptolemy tandem hypothesizes that this has definitely got something to do with the Moon and the Sun going around us. Just look. The Sun rises, the Sun sets, the Moon rises, and it repeats. That just means these two bodies are going around us, right? But if we remember from our earlier science lessons, this isn't the case, is it? This isn't what we were taught. We were taught that the Sun sets and the Moon rises because they don't go around us. The Sun rises and the Sun sets because we spin. That's a day in our calendar. Then, how many spins does it take for us to complete a year? How do we know it's been a year? Copernicus and Galileo says it's not that the Sun and the other celestial bodies go around us. We are actually one of the celestial bodies going around the Sun. It takes us roughly 365.25 spins to complete a year. That is actually a whole revolution around the Sun. How cool! We actually go around the Sun. But then, how do I know this? Here's my question. How do you know this? Yes, I know, but how do the teachers know? Because the scientists know? Yeah, sure, but how? They probably have seen it, sure thing, but why should I believe them if I have not seen it for myself? Mali mo ba pinaglolo ko lang tayong lahat dito? Paawat ka naman. Kagising-gising din, paalala nga ni Bertrand Russell, di ba? Don't be dogmatic. Huwag agad-agad maniniwala, kaya ka nasasaktan eh. As an overthinker, dapat naninugurado tayo. Hindi lang ako yung may masasabi dyan, no? Kolak says we were already ingrained with this information the moment we started learning about the universe. So of course, the answers to our questions are obvious. But as Kolak says, let's doubt the obvious. Let's pretend we really are crazy enough to doubt what is obviously true. Maging delulo tayo kahit alam natin yung totoo. Ayan, hindi na lang ako yung nananakit ha. Anyways, say we can actually go to outer space. Let's be crazy! What's stopping us from checking what the scientists have all been claiming and fighting about? Let's go see it for ourselves. Kolak explains it like this. We go straight up until we are in a synchronous orbit around the Earth. Many satellites are in such a synchronous orbit, meaning that according to the heliocentric theory, they move at the same speed that the Earth revolves, thus remaining in the same position over the Earth. Now, inside our spaceship, looking down from our synchronous orbit, what do we see? Below us is Earth, with the Philippine coastline visible beneath a layer of clouds. The Earth is perfectly motionless. We look up, the sun, the moon, all the planets and all the stars are seen to move around the Earth. Well, of course, we are in the Earth's reference frame. So obviously, up in our spaceship above the Earth, what we must do is start moving about. Staying here and looking down, Earth will remain motionless. To see with our own eyes what the real movement of the solar system, we must first leave Earth's reference frame and go to the sun. We fire our thrusters and retro rockets and fly away until we are in a synchronous orbit around the sun. The air conditioning is very good. What do we see? Lo and behold, we now see the sun perfectly still beneath us and all the planets and the stars moving about the sun. Finally, Copernicus and Galileo vindicated. But hold on, now fly to Mars. Our orbit around Mars, what do we see? The Earth, the other planets, the sun, and all the stars revolving around Mars? So, Mars is at the center? No! I'm just stating what Daniel Kolak has observed from the debate about which is the center of the universe. The thing is, whichever planet we go to, as long as we stay in their synchronous orbit, we will always see the other planets revolving around where we are because of our reference point. Take note of that. Then, you may think, why not go further, outside of our solar system, go beyond the Milky Way? If we shift our reference point on the Earth, the Sun and the other planets will revolve around it. If we shift our perspective on the Sun, the planets will revolve around it, and so on. So, ano ba talaga? We'll further explain this later on with the help of Einstein. But surely, the past thinkers would not have come up with such systems if they did not observe something to be true, in their perspective. May sagot naman sa tanong natin sila Aristotle and Ptolemy, and Copernicus and Galileo. Ang tanong talaga ay, sino ba ang mas kapanipaniwala? Papanig ba tayo sa pinanigan ng simbahan noon o sa pagsubok nila Copernicus at Galileo sa simbahan? Let me first explain why is it that Aristotle and Ptolemy believe that Earth is at the center of the universe through Ptolemy's observation. A phenomenon called retrograde motion was well known even during the ancient times. Retrograde motion means an actual or apparent motion of a body in the direct opposite to that of the direct motions of most members of the solar system, according to Oxford Languages. This means that there are celestial bodies or planets, say for example, that backtrack when they should not do so if there is a unified direction that the planets follow in their revolution around the center. What's puzzling is that the only planets that exhibit this phenomenon are outer planets like Mars, Jupiter, and Saturn called wanderers. Ptolemy and Copernicus alike had explanations for this. As for Ptolemy's, this is because these planets have epicycles, another phenomenon that my friend Ada would explain to us as she compares Copernicus' explanation of retrograde motion using the planets' difference in orbiting speed. You're most welcome.
Hello there, pleasure to meet you. Let's not jump into epicycles first as you were confused after your field trip to outer space. Mahirap talaga pag overthinker ang friend natin. Nakakagulo ng isip. Parang ako lang. So ano nga ba ang sinasabi ni Jazz kanina? To put it simply, we have two challengers. Challenger 1 is the church, who agrees with Ptolemy, who also agrees with Aristotle. And Challenger 2, who is Galileo Galilei, who agrees with Nicholas Copernicus. The church argues that the earth is the center of the solar system. Even the Greeks were backing them up as it was taught as an official doctrine to them. Ptolemy's theory was called the geocentric system, where the sun, moon, planets, and the stars revolved around the earth. Geo means earth and centric means center. Putting it together, the earth is in the center. The church accepts this argument because the Bible, which was the truth for Christians, declared that the earth was motionless and at the center. On the other hand, another model came into place after Ptolemy's theory. This was what Galileo believed in. It was Copernicus' heliocentric system. Contrary to the geocentric system, Copernicus claims that the sun is the center of the solar system while the planets, including Earth, revolve around it. Helio means sun. That is why it's called the heliocentric model, because the sun is in the center. Copernicus was the first to challenge the Aristotelian Ptolemaic geocentric system. However, he put a disclaimer before declaring this due to fear of the church. Baka daw kasi matiwalag siya. Galileo boldly declared this to be the actual truth, contradicting the church. That's why he was placed under house arrest. But is it really the center of our solar system? Sorry, I can't help it. Ang dami kasing sinabi ni Ptolemy sa system niya. Para bang nanggagaslight ang person. Kaya mag-ingat sa mga gaslighters. Sa huli, lolokohin lang kayo niyan. So ito na nga yung sinasabi ni Jazz kanina na epicycles. O diba? Ang daming sinasabi ni Ptolemy. Kung titignan natin, Copernicus' model is more accurate because of the retrograde motion that our friend Jasmine stated earlier. It is the illusion created when we observe the other planets from our moving Earth. This also shows that the planets closer to the Sun are faster, while the others farthest to the Sun are slower. However, they move in the same direction. Look at Mars's orbit. It seems like it's going back and forth. Galileo was able to trace the planet's movements. Now, look at the stars. They didn't move. Sun is a star. So if the stars didn't move, then the sun doesn't move? Proving Copernicus' theory. Moreover, Galileo used his telescope to look at Jupiter's moons, which revolves around it. If Ptolemy's theory was right, then those moons shouldn't exist at all. Now here comes Ptolemy with his epicycles. Epicycles are the orbit of the planets. It is the imaginary circle that the planets move around. Ptolemy says that each planet doesn't just go around the Earth in circles, but it circles around on its own orbit around the Earth. Look at this illustration. You'll see that Mars moves around in circles. This is the epicycle. All planets have epicycles except the Earth. That is according to Ptolemy. Earth, just as what the Church argues, is motionless and at the center. It has its own circle, and that is the eccentric circle, or what is referred to as the deferent. The planets, the moon, and the sun moves in its epicycle, while the epicycle moves in the eccentric circle of the Earth. Using the epicycles, Ptolemy was able to account for the positions of the planets perfectly. Yes, you're right. But Ptolemy was able to predict the future positions of the planets, making it a more convincing theory. Now, Ptolemy is one step ahead of Copernicus. Now do you get why I question the heliocentric system? I guess Kolak was right when he said that Galileo was wrong and the church was right. You don't believe me just yet? I'll give you back to our friend 30. He'll also tell you more about the geocentric system and how it is more convincing. He'll also tell you about how the US Coast Guard uses the Ptolemaic Global Coordinate System because it is simpler.
Naku, huwag na kayo makinig dyan kay Ada and her heliocentric model. Dito tayo sa pinakamagandang model, sa balat ng lupa. Ang geocentric model, where the Earth is in the center. That's on period, babe. Greeks ang mga unang napaniwala that the Earth was at the center of the solar system. Siyempre, nakasulat yan sa mismong official doctrines ng church. So, when Ptolemy found out about it, he called it the geocentric system. Yung effects. So the Bible has many interpretations. So people before interpreted that the Bible said the same thing, that God said the same thing, because there were verses in the Bible saying that the earth is immovable, na hindi siya gumagalaw, it's just there. So people interpreted it that the earth is in the center of the universe. Let's also put some factors into consideration, syempre. Early theories like this one were major discoveries of humankind. Kaya madali talagang makonsider ang theories into fact. Also, when it comes to heliocentrism, medyo mahina pa kasi yung science sa panahong yan. Ikaw ba namang nakatira sa year 100? Sa tingin mo ba, maniniwala ka sa science? Say a scientist says that your body is made up of cells. Maniniwala ka ba doon sa year 100? Eh, yung tipong concept of self pa nga lang, di mo ma-explain sa year 100. Siyempre, di mo ma-explain yun. That's why, people before easily accepted the geocentric system of Ptolemy because it was solely based on God's truth. Dahil nga God is truth without any exception. Hindi lang yan, Copernicus also tried to support his argument for heliocentrism. Kaso, lalo lang talagang nahilo yung mga tao nun. Ang argument niya dito ay within the numerous numbers of epicycles. And I'm gonna try to discuss it to you speedily. Okay, so sabi ni Copernicus, ang epicycles daw ay 48. Kaso, ang required kasi sa Ptolemaic system is 80. So sabi ni Copernicus, 40 na lang. In other words, contrary to popular and even academic belief, Copernicus did not reduce the number of circles but increased them. So from 40, naging 48. Sabi niya pa sa ibang sources on Crombie, Ancient and Medieval Science, 34 daw ang epicycles. Pero, he reduced it again. So from 80, naging 48 according to the history of science. Sabi niya pa, 70 na lang daw according to the nature of physical reality. Tapos naging 80 ulit according to the anticipation of nature. Pero sabi naman sa special theory of relativity, 0 na lang daw ang epicycles. Tapos naging 40 na naman. Tapos, nahihilo na ako. Hindi pa ako nag-almusal, di ba? Tapos ganyan yung sasabihin mo sa akin. Copernicus, ano ba talaga tayo? Ay, kasi ano ba talaga yung number of epicycles? Ganun talaga, kahit si Copernicus nun. So, nahilo talaga si Copernicus nun dahil, di ba, paiba-iba rin yung answers niya. So, super uncertain nga niya pagdating sa heliocentric system. Well, both of the systems were complex and medyo, di ba, alanganin pa. Pero in the end, sa dalawang systems, pinili ang mas simple at mas kapani-paniwala. And which of those is the more simple? The more demure, the more supple, the more believable? It's the geocentric system, of course. So the Ptolemaic system never dies. Actually, it is currently playing a vital role sa US Coast Guard. Pero why? For what? Diba? So, dahil nga sa practicality nito pagdating sa calculations, pag nag-navigate tayo ng celestial bodies accurately, yan ang ginagamit. Though more on the scientific side nga yung heliocentric model, pagdating kasi sa celestial navigation, we view movements of stars and planets from the point of view of the Earth. Pag kasi ginamit mo ang heliocentric model sa pag-navigate ng celestial bodies, syempre, you're coming from the point of view of the Sun. But when you use the geocentric model, where the point of view is from the Earth, syempre mas madali ang pag-navigate ng celestial bodies. How far they are from us, how fast they are moving. So mas madali, mas accurate, and mas practical for us humans na we're just trying to discover some things. So of course, in the end, tunay na nagwagi ang geocentrism.
Now, why is it so that we are so sure of whichever model we believe in? All that discussion in geocentrism, heliocentrism, epicycles, etc., etc., how did the church and the scientists decide which was the truth to be told? The church believed in the geocentric model because they believed that a theory explaining a different system would have to have been revealed by God. They believe that the earth is the center because it suggests so in the story of creation set in the earth itself. It would only make sense that the earth is the center. In Smart Kids 100 Awesome Bible Stories by W.S. Pacific Publications Incorporated, they narrate the second and fourth day of creation like so. On the second day, God looked around and saw water around him. God split the water right in the middle, and he called the waters above sky and the waters below sea. Then he gathered all the water below until dry land appeared. And God called the land earth. God saw that it was good, but there was something missing. On the fourth day, God once again said, "Let there be light." Twinkling lights appeared in the sky and shined above the earth. Now the sun kept the days bright, and the moon and the stars lit up the night. God said it was good, but there was still something missing. This explains Kolak's interpretation of the church's belief that Galileo cannot tell just by looking, because they believed it had to have been a divine revelation. Nonetheless, the statement "you cannot tell just by looking" is true. How so? Remember what I said about us shifting our perspectives and how Einstein will help us answer the question of why it's also inconsistent when we focus on one planet and then another? Kolak says, indeed, as Einstein showed in his theory of relative motion, there is no absolute vantage point in the universe where we could stand to see what the true motions of anything are. The only absolute thing about motion is that it is relative.
We are indoctrinated by the beliefs of science, thus making us a member of the faith that Kolak describes as the greatest religion that has ever existed, and that is the Church of Science. The Church indoctrinates its belief and practices to its followers. The indoctrination is like a religion teaching their faith to its believers. On the other hand, science was indoctrinated to us because we learned to accept the facts from the scientists with unquestionable certainties. Science is a cycle of nearing eureka. Scientists always argue that they are on the verge of proving their theories. However, after some time, it will get debunked as another theory arises. As philosophy ponders, questions, causes, reasons, and investigates certainties, though science possesses it to be true, it paves way to new theories to think about, which eventually expands our existing knowledge. Even the most basic facts people accept as true can still be debunked once new theories are proposed.
With all said and done, this debate highlights true philosophical inquiry, which is the relentless pursuit of knowledge, whether from the perspective of faith or science, Both sides contribute to our understanding of reality. The Church of Science may offer a methodical and empirical approach to uncovering truths, but as Kolak suggests, even scientific truths are still subject to revision or even falsification. The lesson here is that neither science nor religion offers an absolute final answer. Both are valid, though, in their own right. What matters most is us maintaining a critical and open-minded stance. So, we cannot always be guaranteed that certainty won't always be certain. Yet, what we consider as truth today may merely be just another stepping stone in search for knowledge. Ultimately, the pursuit of truth is not just scientific, but deeply philosophical.
All of this discussion on what is the center of the galaxy has become an eye-opener on how equally oppressive science can be with quote-unquote religion. Science, given its systemic methodologies, can't possibly be questionable. We realize that until we observe that we go on a cycle of being on the verge and debunking almost eurekas once again. Theories then that are discredited now, theories now that will be discredited in the future, makes us all contemplate whether or not we should put all of our eggs in the basket of science. If we do so, it makes sense to look back on our first reading of Bertrand Russell, who disvalues an enclosed mind hindering philosophic contemplation. Russell says, the value of philosophy is in fact to be sought largely in its very uncertainty. In these questions we ask, questions the scientist asks that the fad of being on the verge of things, we keep alive the speculative interests of the universe. If we become gullible and entrapped on what is known and what is taught, succumbing to the Church of Science, we become one of the practical men. In this discourse, if uncertainty is the core of how we discover things, there is one thing we can hold on to. René Descartes knows this. He could be deceived by his evil senses and an evil genius, but he could not doubt the fact that he was doubting.
The Church of Science allows us to question and doubt what is certain. This allows the constant flow of discoveries and knowledge. As we are always on the verge of discovering facts, we always try to find the absolute truth. That is where philosophy comes into place, because the value of philosophy is to continuously question things. Being open-minded to possibilities frees us from the chains of certainty and dogmatic beliefs. It tells us to explore various possibilities that the world may offer. The man who locks himself with definite beliefs, rendering himself stagnant and conservative, refusing change, will never grow and will stay ignorant. When we stop questioning things, we box ourselves with our own ignorance. Just like in the concept of the allegory of the cave, we isolate and confine ourselves from the real world, hindering us from the actual truth.